Now we are going to start with squint, also known as strabismus. Okay, squint, also known as strabismus. So what is squint? We just studied in our previous videos. Now we're going to discuss about the classification of squint, that is apparent deviation and a true deviation. These are the types or classifications of the squint. So what is basically apparent deviation? It is a pseudo strabismus. So it apparent, the name itself tells us appears like deviation. Okay, so that's why we called it a pseudo one. Okay, so the deviation appears, this squint eye appears as it is a squint. Okay, the eye appears as it is a squint, but it is not a true squint. So the next, the true squint or the true deviation, what is it? There are two types of true deviation. These are heterophoria and heterotrophia. Remember the words phoria and trophia. This is a latent squint, and the heterotropia, it is a manifested squint. What does the word manifest means over here? It simply means us that there are signs and symptoms present over here, and the latent one, the phoria, is nothing but the signs and symptoms are absent over here. Okay, very simple. Now what is latent squint? Let us see. Latent squint is nothing but hidden deviation which may be because of, which may be due to of ocular stress. So there are hidden deviation due to ocular stress. For example, excessive work in dim light. The manifest squint is further divided into two subtypes. These are comitant squint and incomitant squint. Okay, let us see what is comitant and incomitant in a form of difference. So, comitant squint and incomitant squint. The degree of differentiation remains same in all the directions of the gaze. Okay, here the degree of differentiation, okay, the degree of deviation, the deviation or differentiation of the both the eyes remains same, and it is in all directions, whereas the degree of deviation here varies and with the gaze. Okay, and it is not in all directions. Very simple. The important point over here is primary deviation is equal to the secondary deviation in concomitant, and in inconcomitant there is primary deviation is lesser than the secondary one. Okay, remember this students, very important point. Now the ocular movement over here is normal and the ocular movement here is restricted. Okay, so restricted ocular movement in incomitant. Now diplopia and head posture is absent. Okay, and diplopia and head posture is present over here. Sensory abnormalities are present over here and sensory abnormalities are absent over here. So in a very simple form, this differentiation, and the most important point is this, must to remember. Further, the incomitant squint is divided into two, that is paralytic and a restrictive squint. Let us see this. So incomitant squint, the test between the paralytic and restrictive squint is done, that is known as FDT, also called as forced duction test. Okay, this test is done to differentiate both these paralytic and restrictive type. These are of incomitant squint as we saw. Okay, now this FDT is a diagnostic test and it is for the restrictive squint. Okay, and it is for restrictive squint. The method include, you have to hold the eye with a forceps and move it with external forces. Okay, so you have to hold the eye by a forceps and you have to move the eye by a external force. What are the results of FDT or force duration test, it is movement occurs if the eyeball is moved or if the eyeball doesn't move. It depends upon the two. The result depends upon whether the eyeball is moving or whether the eyeball is not moving. If there is a movement, then there is no restriction over there. Okay, if the eyeball is moving by the external force, then there is no restriction over there and the test is negative. Okay, and this is a paralytic squint. This could be a paralytic squint. If the eyeball doesn't move, then this would be a positive squint because there is restriction present over here. Okay, if the eyeball doesn't move with a external force, then it is positive test, and this is a restrictive squint. Very easy. So that was all about paralytic and restrictive squint. Now comes the directions of deviation. Okay, so the direction of deviations, these are isodeviation, exodeviation, hyperdeviation, hypodeviation, encyclo and excyclodeviations. Let us see them one by one. So what is isodeviation? Isodeviation is nothing but inward deviation of the eye. So assume this as a normal eye, so the deviation would be over here. Okay, inwards deviation. Then another comes the exodeviation, exodeviation, also called as exotropia. So exotropia would be the outward movement of the eye. Okay, so this is the outward movement of the eye. Here would be somewhat the eye. Okay, here there would be somewhere. Okay, like this, the eye has gone at the periphery over here. Okay, this is the normal eye. Now another thing comes is hypertrophia and hypotrophia. So right and left. So in the, if it is right, then it would be in a right eye. Okay, if it is left, then it would be in a left eye. Very simple. What is hypertrophia? So hyper means above, so the eye would be going above. Let's see, like if this was your normal eye, okay, then the eye is going here somewhere. Okay, this is hypertrophia. If this was the normal eye and there was hypotrophia, then the eye will be going downwards over here. Okay, very simple. This image at above, this is hypertrophia, left and right respectively, and hypotrophia, the eye is going downwards. Okay, in the right one, and in the left one it is going downwards. So very simple, hypotrophia and hypertrophia. Hypotrophia is nothing but downward displacement of the eye, and hypertrophia is nothing but upward displacement of the eye. Now to another very important terminologies, these are encyclotrophia and excyclotrophia. Encyclotrophia is the inward deviation, deviation, okay, from its axis. Assume this as a normal axis. This is the normal axis, and inward deviation. So the eye would be deviated here. This is encyclotrophia. If the eye is deviated outwards, this is excyclotrophia. Okay, and this is the normal axis. Simple. So that was all about the topic. Now we'll start with the squint test.